Okay, so this video we're looking at rates of change. So let's get straight into it. So what is rate of change? Rate of change is the gradient, so how steep something is, either between 2 points, okay, which if you do that, that is the average rate of change, or the gradient, again the steepness, but this time at a single point, okay, which we call the instantaneous rate of change. So at the GCSE level, there are two types of rate of change. You've got the average rate of change, which is between 2 points, so something like this, where you've been given some sort of graph or curve or whatever, and you find the rate of change between 2 points, like we can see here. So you would find the gradient between those 2 points. So maybe you're thinking, oh, okay, gradient of a line, I can do that. Absolutely right. That's pretty much what this is on about. But also you can find the instantaneous, okay, rate of change, which is at a particular point. So if you had something like this again, but you wanted to find the gradient at a particular point, so I've chosen a random point there on the graph, which is 4. To get the gradient at a particular point, you need to draw in something called a tangent line, okay, which is a line that is cutting through that point exactly one time. And you're trying to get it to roughly match the steepness as best you can of that curve. Okay, so that's just a pretty brief introduction to what rate of change is all about. So there are two types, average and instantaneous. Okay, so you can make a note of that if you need to. So you'll see in another lesson why the rate of change, or the gradient, is useful in real life applications, right? And if you go on to do A-level maths, this is really, really useful. Okay, so some applications, for example, if you find the rate of change, or the gradient of a speed time graph, okay, so this here, let's go and highlight so we can see what's going on. This is a speed against a time graph. If you find the gradient of a speed time graph, you get acceleration. Okay, I'm not going to go into why for the time being. It's to do with the units, but just like know, right, in context, rates of change are really useful. So if you find, in this case, we're finding the gradient at a particular point, okay, which is instantaneous rate of change, because you're finding the gradient of a speed time graph, that actually would get you something called acceleration, which is nice, okay? So this is an example of instantaneous rate of change because we're finding the gradient at a particular point, 1 point, as we can see there, okay? Or you could find the rate of change of a different kind of graph. So that one was a speed time graph. But what about a distance time graph, like we can see here? If you find the gradient, okay, of a distance time graph at different points, okay, you will get something called speed. Okay, so we're just seeing the applications here of rate of change. So for example, between these 2 points here, if I found the gradient of this line here, which is just finding the gradient, the average gradient, because it's just a straight line, okay, it would be so this is an example of average rate of change because you're going between 2 points. Okay, so you'd be finding the average, in this case, speed, because that is what the gradient of a distance time graph is. So that will give you speed, okay, between those 2 points there. Okay, so that's just a bit of an introduction to what rate of change is. So we've got two different ones. We've got average, we've got instantaneous, and we've looked at some applications of when it might be useful. So that's kind of useful to spot it in exam questions, potentially. Anyway, right, let's first begin by looking at average rate of change, which again is the 2.1. So it says, right, estimate the average rate of change, the gradient of y between x is equal to 3 and x is equal to 5. Well, let's begin by plotting those points on our graph. So, right, first of all, right, again, gradient, is equal to the rise, how steep something is, over the run. Or you could say the rise is the change in y over the change in x. So I've plotted the point here when x is equal to 3. I've just gone down here and plotted that point there. That's what I've done there. And the same thing with 5. There we go. Okay, I'm just saying that the coordinate at this point here, when x is equal to 3, if I read across, I get my value of minus 2 for y. And similarly, when x is equal to 5, and I read across for y, I will see I get a value of y of 6. Okay, so I've plotted my 2 points, 3 and 5, which then give me my corresponding y values. So to get the gradient now between these 2 points, this is just a gradient. This is grade 5 stuff between 2 points, which is going to be, okay, join the 2 points up with a straight line because we're looking at the average. And I draw in my triangle because when we find the gradient of a line, we go and draw on our triangle. And we're saying, well, we're going across in the positive direction by 2 units. Okay, so from 3 to 4 to 5 up by 2. And then we're going up by positive 8 units. Okay, going up by 8. So putting this into our formula for gradient, because that's what rate of change really is, right, we're saying that the rise is equal to 8 units up over the run, which is across by 2 units. So the gradient is equal to 4. And that is it. Okay, the average rate of change, or the gradient, And there's no context here, so we're just saying it is equal to 4, whatever it is, 4 units. Okay, so average rate of change between 2 points, and that is it. Okay, this time we're looking at instantaneous rate of change, which is a bit more tricky, but nothing that we can't handle. So estimate the rate of change of y when x is equal to 0. So it's just saying, right, first of all, okay, again, right, rate of change is just talking about finding the gradient. That's what it really means, okay? And it's just given us x equals to 0, which is a single point. So we are definitely talking about instantaneous, a single point rate of change. So the point x is equal to 0 is up here. Okay, this is the x-axis, and x is 0 is just not moving along. And when x is 0, the y value, okay, there, well, it doesn't even matter, it doesn't matter. Right, and I mentioned at the start, to find the gradient or the rate of change at a particular point, you need to draw in a tangent line as close as possible that matches the gradient, right, of your curve. And it must only go through the curve, which I haven't done there, at exactly 1 point. So if you drew a tangent line like this, right, that's ridiculous because it doesn't match the gradient at all of your curve, right? It's got to be really, really close, matching to the gradient of the curve. So there we go. I've put one in there because it's just is much neater. So this line here, right, we can see it's matching pretty much, if I highlight it, sorry, to make it even clearer, it pretty much exactly matches the gradient of that curve as best as I possibly can. So I'm estimating the gradient at that particular point. So I can't go and draw that in because, you know, I'm trying to get the gradient at this point here. So that's a good line. That's a good tangent line. Okay, and it touches at exactly 1 point. So once I've drawn my tangent line now, I just got to go and find the gradient of that line. So again, I choose 2 points. I go and make my triangle. Okay, or I'm going to begin with, right, to go from this point to this point over here. And it doesn't matter which way you go, as long as you're consistent. I'm going to start here to go from here down to here. That is down by -8 because I'm going in the negative direction. And then to get from here to here, and then from here to here, I'm going across in the positive direction by 2 units. Okay, so my rise this time is -8 and my run is 2. So, so my gradient is going to be, the rise is -8 over the run, which is 2. So the gradient at that particular point using my tangent line is equal to -4. Okay, and that is my answer. And again, there's no context here. There's no units like speed and time or whatever. It's just -4. Okay, so it's quite important that when you draw on that tangent line, you get it as close as possible to the gradient of that line. So for example, if I wanted to find the gradient at that particular point, okay, that is a terrible tangent line because it doesn't even match the gradient. It's got to be really, really close to the gradient of your line. Okay, it's hard to draw on this because it's a bit sensitive. Okay, so that's instantaneous rate of change. So before you try the your turn, okay, right, it's really important to bear in mind you may be asked for the rates of change in many different contexts, as we kind of briefly mentioned already. So, but really, right, the key things that you're looking out for, because they're not going to expect you at the GCSE level to, know what things are in context at this stage. You're just looking out for the keywords average rate of change between 2 points, which is where you choose 2 points and you get the gradient between those 2 points. Or they might say the instantaneous rate of change. So you're looking out for that one keyword, which is like where you've got a curve and you're given a point and you find the gradient at that particular point. So that's what you're really looking out for, not the context at GCSE level. Okay, so yeah, there we go. Knowing this, you don't always need to understand the context of the question. You just need to kind of recognize between 2 points is average, instantaneous is 1 point. So let's try this one here. So look, it's going to be hard for you to try this, isn't it? Because you haven't got the graph in front of you, but you can kind of think about what you would do here. So below is a velocity time graph. So this time they've given us some context, which is nice. So we've got a velocity against a time graph, okay, of a particle over 12 seconds. So it's over a period of 12 seconds, which we can see. Find an estimate for the particle's acceleration. Right, and that's where I'm talking about... Right, it's just fine. You might be thinking, well, how do I get acceleration from this? Well, acceleration is gradient. But if you didn't know that, it's saying find the acceleration at time 6 seconds. So that is the giveaway. That is saying we've been given 1 point, so it's going to be instantaneous rate of change. So you don't even need to know that in this case gradient or rate of change. from a velocity time graph is acceleration. We're just knowing at 6 seconds, which is at this point here, time is 6 seconds, time is there, that is 6. Okay, I want to estimate the gradient. So for this one, it's only 1 point. I go and draw in a tangent line to that point that closely matches the gradient at that particular point. So that's a pretty good one, right? That would be, of course, not great. That's obviously a shocker because it's nowhere near the gradient at this particular point. So I've drawn it on screen already, which is nice. And then again, to find the gradient of this line, you go and choose 2 points, and those points could be anywhere, right, on that line. So I've just chosen these two here, but it could be anywhere. I could have chosen this point here and this point here, but I've gone for these two because these are quite easy to read off relatively. And I go and draw my triangle, which is going 10 units across in the positive direction and then up by 11 units also in the positive direction. Okay, I could have gone from here down, which is minus 11, and across by minus 10. It would give me the same answer because the negatives would cancel out. So the gradient, the rise is up by 11 and the run is across by 10. So my gradient, which in the context of this question, gradient of a velocity time graph is acceleration, is 1.1 meters per second per second. Okay, but the key thing is, that we're looking at 1 point, you draw on your tangent line, and then we find the gradient of that tangent line. Okay, that is it for rate of change. Thank you.